Hey everyone, it's been a while. It's been a hiatus, but I'm glad to be back. Glad to be creating some new content for all of you. And today we're going to actually generate some strike zone heat maps based on each individual quadrant of the zone. And so I already put the CSV file on GitHub because people have asked, "Hey Robert, how do you put the CSV file on GitHub? Or how do you grab it?" Because most people will like copy and paste, and I'm going to show you a quick way to be able to just pull it straight from GitHub. So when you go on the page, so the title is Generate Heat Maps by Zone using GM Tile, and you'll have an example Trackman file. We're going to be using college data, but again for anonymity and security reasons. I reduced the columns and then changed the batter name to just example left-handed batter and example right-handed batter. So what you're going to do here is you're going to click on raw. And when you click on raw, I'm not sure if you can see it, but it'll generate like a comma delimited file. You'll just copy that link when you click on it, and then you'll paste it into the file, which I will show shortly. Now that we're back in R, we can see that this is basically the final output that we're going to generate. And the way of doing that is obviously through code with R, so we'll get right into it. So we're going to load in our library, tidyverse, and that will be loaded in. And again, like it may not appear as a message for me, but it might appear messages for you. That's perfectly fine as long as it doesn't say error. And then this is where we will read in our CSV from the copy and paste. So Trackman, I'll just call it TM, read underscore CSV, which is under the readr package, which is under tidyverse, and then in quotes, we'll add in that URL. And we'll run it. Loads in. It'll give you comma delimited files. There's 8 columns. And the easiest way to kind of skim the data is head. Yeah, so I'll run that. Give it a second to run. And it'll show you the 8 columns that we have. So we have vertical and horizontal pitch location. We have batter, which again is just example left-handed batter, example right-handed batter. Pitch call, pitch, exit velocity, launch angle, and distance. Now you can repurpose this for pitcher. I just had it as batter. And you can see like from the plot that Trackman does it from the pitcher's view. So we're going to generate it as such. So let's get directly into it, and I'm going to create a function. And the beauty of functions is whenever you want to do like multiple zone data, so if you want to do multiple heat maps of someone, you don't have to like rerun all of this code and like change the name over and over again. The function will just make it so you can just run this function, insert the player you want, and be able to change and go back quickly. So get zone data is the function I'll call, and then it'll have 3 arguments. We'll say df, which is short for data frame, player, which is short for obviously player, and then type. And I'll actually create an argument within the original function called with. So that's kind of the example that I showed you earlier with percentage. And then we'll add in our squiggly brackets and we'll get started. So df. So basically we're taking this data frame here in the top left, calling it by creating a new variable called df, and we're going to add a piping operator, and we're going to mutate. And this is from Baseball Savant. So we're going to do a case when I'm going to copy and paste code, but I'll more or less show you like how it works in a way. So I'm actually going to remove that. And again, it'll be on GitHub with the code, but if you want to type it out, you can. Basically, I'm creating the quadrants of the zone that is similar to Baseball Savant. So when I go to Viewer, I'm creating these quadrants of the zone. So 1 is the top left, 2 is the top middle, 3 is the top right. Again, this is assuming from pitcher's view. I know Savant has it as catcher's view, but we're treating the zone as pitcher's view because the Trackman data is from pitcher's view. So we can see these values are just basically splitting the zone into thirds, both horizontally and vertically. So being able to go from 0.28 to 0.28 is the middle, 2.9 to 3.6 at the top, 2.2 to 2.9 middle, 1.5 to 2.2, and then being able to generate that value for that zone. So that's the original way of doing it. And then we're going to add some other things. So like whiff equals if else, pitch call equals strike swinging, not spell swinging, 1, otherwise 0, which is basically saying, assign it as a whiff, otherwise don't, if there's a strike swinging. And then same thing for swing, if else, pitch call. And this is a good way to use the in operator, which the in operator allows you to basically combine multiple elements. And in this case, we are. So we're going to do foul ball, in play, and strike swinging, which just basically means, hey, if the pitch call has those 3 elements, either give it a 1 or give it a 0. And then the last but not least part is take, if you want to view take. So if else, pitch call, again, in, and then we're just doing 2 elements, ball called, strike called. Now, if you do have access to a Trackman file, the column names will be slightly different. I'll leave you to try to figure that out, which columns are different. So, like, obviously, I have everything in lowercase. I know Trackman does not spit out lowercase columns, but this file will have lowercase columns. It makes it simple to me. And then we'll add another piping operator to continue our code, and then we'll go into filter. So you can type out filter. I'm so used to typing out dplyr filter because, again, sometimes there's code that sometimes there's packages that have filter, and it's like, which one you're trying to call. And then we'll say batter equals player. And again, if you want to do it on the pitcher side, just change this to pitcher equals player. So that way you can filter based upon that pitcher. And then same thing here. So dplyr, group by, batter zone, or pitcher zone if you have Trackman pitcher data. And then we will summarize. So there's a few things I like. So like N is the total number of pitches. Whiff equals, not with a J, whiff equals sum. Whiff. Swing equals sum. Swing. And then take equals sum take. And then we'll add in a few more things. So like I will add in average EV, which is mean EV, NA.rm equals true, and then max EV, which is max EV, NA.rm equals true. The reason why I'm doing NARM equals true, which is removing NAs, is because some values have NAs for exit velocity, but for swing, whiff, and take, since we assign those variables as either 1 or 0, it's going to have 1 or 0. It's not going to have any NAs, so we don't need it there. Then we're going to do some other operations. So we're going to ungroup the data so we can mutate again by doing this. So mutate, I'll call it whiff PCT, which is whiff percentage. We're going to do 100 times round whiff divided by swing 3. And then same thing for take percentage and swing percentage. So 100 times round take divided by swing 3. So really, rounding to 3 decimal points after multiplying by 100 is really rounding to 1 decimal point. just makes it easier. So if it's like 20.5%, it'll originally go as 0.205, but then multiplying by 100 will make it 20.5. And then swing PCT equals, same thing, 100 times round, swing divided by pitches, 3. And then add in the other one, so average EV. We'll just round it to 1 decimal place, and then same thing for max EV. Round, max EV, 1. So, with that being said, let's do a simple if statement. So, remember when we mentioned the type argument up in the top? So I assigned it type. So I'll say if type equals with the double equal sign with, then we'll do these operations. And basically what we're going to do here is generate those zones. So I'm just going to copy and paste code just to make it easier on you and save time. I figure you don't want to watch a 40-minute video. Try to keep it time friendly. But basically what we're doing here to generate this heat map that is right here, we're pulling that width percentage by each zone. So each Z1 through Z9 is pulling that zone and then pulling that width percentage within that zone. And then we're going to create a new data frame called DAT. And what DAT does is creates kind of that boxed area where we're taking the edges of the plate, which is negative 0.83 to 0.83, and then we're taking the values of 2, 3, and 4 for the vertical side, and then combining it with the value of each zone. So it's not like a perfect set in zone. So like the reason why I'm using 7, 8, 9 first is because I'm going bottom to top. Now, if you want to go top to bottom, you'd go 4, 3, 2, 4, 3, 2, 4, 3, 2. But in this case, I'm just doing 2, 3, 4. And then we will build out our plot. So P, I'll call it P. Call it whatever you want, but call it P for simplicity. So I'll say ggplot dat, which is the data frame we just called. AES x equals x, y equals y, and then fill equals value because we're taking the x from here, the y from here, and the value from here. And then we are going to add that geom tile. So geom tile color equals black. You can put whatever you want, but it's just as a base to allow kind of those black areas here with like the vertical lines and horizontal lines. And we'll say geom text and then add our aesthetic, which is important. So that allows us to put the value within the plot. And then we'll say color equals white. And size equals 4. Now you can change the size of the text. You can make it 5, you can make it 6, whatever you want. And then now we're going to use that gradient fill, so scale fill gradient, which basically what this does is allows you to create a heat map based upon those percentages. So I will do low equals blue and high equals red. And basically what that does is it allows you to generate, hey, this person's whiff percentage is 43.5, so that's very red. This person's whiff percentage on the nose is 14%, so that's blue. He doesn't whiff as much there. This allows you to see that. Now what I'm going to do is add code by copying and pasting. And if you have ever looked into ggplot themes, like Theme Classic is the one I use a lot. So this is what I'm doing here. So theme x is text, x equals element blank, text x equals blank, text y equals blank, text y equals blank. Basically, if you just want to use theme classic, you can. I just had to make a minor thing to remove the legend position because I don't want the legend in the plot. So I just added that column. Again, if you just want to use theme classic, you're perfectly capable to do so. And then now we're going to draw out the home plate area. So again, more copy and paste code just to make it easier and just to save time. So we're going to do geom segment. And so it goes AES X equals negative 0.708, and then it goes to 7.08. So this segment draws this straight line here. This segment from negative 7.08 to negative 7.08 from 0.3 to 0.15 draws this line. The positive side right here draws that line, and then these two will draw the somewhat vertical lines to the plate. And so I did size equals 1 for all of them, and then the color being black. And so I'll give you a second to either copy that down, but again, all the code is posted in GitHub. You can draw that out. But being able to look at that, and feel free to pause the video if you just want to look at it and then copy and paste it accordingly. So there's geom segment AES, 2 parentheses, so then you need a parentheses here and one here, and then being able to do X, Y, X end, Y end. And so that will draw our segments. Don't forget the plus signs after the end of each one as well. Then we'll get to our last part, which is generating that title. So I will say GG title, and then I'll say paste, because we'll say player, and then to upper type. And what basically to upper does is makes it all caps. There's not a base R way of doing to title case, so we're just going to leave it as all caps, and then at the end we will add in percentage. So that is how we'll get with percentage. So here's how we can do swing percentage, or actually let's do EV, because with swing percentage, just replace this by saying else if type equals swing, and then instead of pulling with percentage, you pull swing percentage. But now we're going to do else if type equals average EV, or type equals mean EV. And basically what we're saying is within that type argument, instead of typing in with, you type in average EV or mean EV. It allows you to do this. Now I'm going to pretty much copy and paste that code that I showed you from earlier. So I'm literally going to do this. Ready? Copy. And then paste. And then instead of, I'm going to highlight this area and then Control F or Command F if you use a Mac. Go with PCT. Make sure it's in that selection and then replace it with average EV. So just to save a lot of time there. So boom. But now we're with ending our if statements, right? We want the function to return something. So outside of the second to last bracket, but before the last squiggly bracket, we're going to add in a return statement. And the return statement will be P, because P is shorthand for the plot. So that being said, let's run get zone data. So we run that, and now it shows up in our environment as a function. So we will run get zone data, and we'll go TM, and our player will be example right-handed batter, and our type will be with. So we run that. It'll give you that. It'll pull up that same plot. Now let's look at average EV. And look at that. So that function allows you to run that code much quicker. So now let's do the left-handed batter. So example, left-handed batter. Run that, and then you see his average EV. It's best down the middle, and it's fairly good on pitches inside. And then you go to whiff percentage. So whiff, and you can see that going up and in or up and away are his greatest whiff percentage, whereas is not whiff at all on pitches low and away. So that's more or less it from the video. Feel free to add in the swing or take percentages using the else if and the max EV. I'll leave that to you to kind of help you learn and help you figure that out. But if you have questions regarding it, don't hesitate to reach out. My DMs are open on Twitter, or you can message me on GitHub. Multiple ways to reach out to me, including YouTube, not just in the comments as well. But thank you so much for watching. I really hope that you learned something about generating these heat maps by zone, and I hope you can apply it to your school, especially if you have a Trackman. That allows you to just make easy heat maps, and it's very readable and very easy to tell, hey, this is for this batter. And then on the reverse side for pitchers, again, you can change that accordingly within that function. Or if you're really good, you can add in another section where it's type equals whiff, or, side, and you can do batter or pitcher and then adjust accordingly. But next time, we'll do this with baseball savant data. It makes that a lot easier. But again, thank you so much for watching. I hope you have a great day.